What's up, everyone? Welcome back. Patrick here. Moving on to the next example. We have to solve this limit here. Limit as x approaches 9 of 6 minus 2 root x over 5 minus the square root of 2x plus 7. So hopefully you could tell with this limit we're going to be using rationalization with all of the square roots involved. And we're actually going to have to rationalize this twice. We're going to have to rationalize the numerator and the denominator as well. And I did an example like this in a previous video, but it was with other examples. So I wanted to do an example just on its own where we have to use this method. So first thing to notice, if we do a direct substitution, what's going to happen? We're going to end up with 0 at the top and then 0 at the bottom, right? Square root of 9 is 3, 2 times 3 is 6, 6 minus 6 is 0. If we plug in 9 over here, 2 times 9 is 18, plus 7 is 25, square root of 25 is 5, 5 minus 5 is 0. So it's in that indeterminate format. So what I'm first going to do is I'm going to rationalize the denominator. So what I'm going to do is I'm going to take this entire expression and multiply it by the denominator's conjugate. So it would be 5 plus the square root of 2x plus 7. And then the top, I'm going to do the same, like that. And so what we would end up having is we'd have the limit as x approaches 9. Now the two terms in the numerator I'm going to keep separate. So 6 minus 2 root x times 5 plus the square root of 2x plus 7. And then over here, that's a difference of squares. So we just have to multiply the ends. So 5 times 5 is 25. Then we'll have minus the square root of 2x plus 7 times the square root of 2x plus 7 would give us just 2x plus 7, like that. And then if we further simplify this, notice that in that denominator, we can distribute that negative. So what would happen is we would end up having 25 minus 7, which would be 18, and then we'd have the minus 2x, like that. So now notice at this stage, if we do a direct substitution, we're still going to end up getting 0 in this bracket, which would make the whole numerator 0, and we're also going to have 0 in the denominator if we plug in 9 for x. And notice that there's nothing that cancels out yet. Usually when you do rationalization once, then what happens is you're able to cancel out this factor with a factor in the numerator. But notice in this case, can't really do anything. In fact, we can simplify this, and I'm actually going to simplify it now. What we can do is we can take out a 2 from the top. You don't have to do this step, but whenever I see any potentials to simplify, or any opportunities to simplify, I usually take them. So we could take out a 2 from this bracket, which I just did. We could take out a 2 from the bottom to get that. And then notice that these 2's would cancel out. So it doesn't, it simplifies things, and it's going to allow us to simplify less at the end. You don't necessarily have to do this step, but I did it. It simplifies things, but it still doesn't, we still have to rationalize the numerator. Because notice, even after we simplified, after we took out that 2, factored out that 2 in the numerator and denominator, we still can't cancel out this 9 minus x with this factor or that factor right there. And so what we got to do is we now have to rationalize the numerator. We got to rationalize this factor. So what we would do is we would multiply all of this by 3 plus root x. 3 plus root x. Now, if you didn't simplify, as in you didn't factor out the 2, then at this point what you would do is you would rationalize by multiplying by 6 plus 2 root x over 6 plus 2 root x. Like that. That would be the conjugate of this bracket. But notice that because we simplified, the conjugate that we're going to be working with is a lot more simple. If you did it this way, you would still get the same answer in the end. It's just in the end you'd have a little bit more simplification to do. So at this point, what we can do, we'll have the limit as x approaches 9. Now, 3 plus root x times 3 minus root x, that's a difference of squares right there. So that would end up being 3 times 3, which is 9, minus root x times root x is x, like that. This bracket would stay the same. And then this and this I'm going to keep separate. So we'll have 9 minus x, and then we'll have 3 plus root x, like that. And now notice the 9 minus x's cancel out. Right? So one more time, we had to rationalize the denominator here, and then we rationalize the numerator. So we had to rationalize twice. We had to do a double rationalization. And now, at this point, because that 9 minus x went away, we can now plug in that x value of 9 because we're not going to have a denominator of 0 anymore. So if we plug in 9 for all the x values, we'd end up with 5 plus, over here would be 25, square root of 25 is 5, over 3 plus the square root of 9, square root of 9 is 3, 3 plus 3 is 6, so we'd have 10 over 6, which would give us 5 over 3. So that there ends up being the final answer for this limit. So just be on the lookout for these kinds of limits where you're going to have to rationalize twice in order to get the answer, in order for that factor to cancel out. And again, if you rationalize this factor, if you didn't do that simplifying with factoring out the 2, you should still get that same answer of 5 over 3.